Hey guys, welcome to Pepcoding. So in this video, we are going to discuss our new question of searching and sorting series, that is allocate minimum number of pages. So let's discuss what this question says. This question says that you are given n number of books. Every ith book has AI number of pages. Okay. So first of all, we will be given n number of books, and every ith element that is in our array of size n. Every element represent the number of pages in that particular book. Okay. So we have to allocate books to m number of students. Okay, we have n number of books and we have to allocate them between m number of students. Okay, there can be many number of permutation to do so. It means there are many ways to allocate books in between, among them four students, among them m students. In each permutation, one of the m student will be allocated the maximum number of pages. Okay, all right, I'll explain it to you. Out of all these permutations, the task is to find out that particular permutation in which the maximum number of pages allocated to a boy or a student is minimum of those in all the permutation, and print this minimum value. Okay, I'll explain it to you later, but the main thing that the constraint we have to read is in the third line, that is each book will be allocated to exactly one student. Okay, it means we cannot allocate the same book to another students also, like we cannot allocate this a single book to many students. Okay, and each student has to be allocated at least one book. It means there should be at least one book allocated to a student. Okay, it means that if I have four books and I have two students, that doesn't mean that I allocate all my four books to only one student, and one and second student is allocated with zero books. Okay, we don't have to do that. We have to allocate at least one book to every particular student. And I mean, we can allocate more than one book to a student, but we have to allocate them at least one book. Okay, and not written -1. If a valid assignment is not possible, an allotment should be in contiguous order. So let's explain what does this say. First of all, let me make an array. Like, okay, so here let's say I have five books. Okay, first has 20 number of pages. It has 10 number of pages, it has 30 number of pages, it has 40 number of pages, it has, let's say, 25 number of pages. All right, and I have let's say my m is equals to, let's say I have let's say I have 3 students to allocate book. Okay, so what are the maximum possible allocation combinations that are possible here? So let's say here, if I allocate, so these are my maximal possible combination. So let's say if I allocate the first book to my first student, second student book to my second student, all right, and all these 3 books to my third student, so the maximum number of pages that the third student has to read will be equal to what? 30 plus 40 plus 25, that is equals to 95. Okay, now another possible combination can be, that is I allocate the first and second book to my first student, so it has to read 30 pages. Third book to my second student, that is it has to reach 30 pages, and 40 plus 25 pages, like these 2 books to my third student, that so it has to reach 40 plus 25 student books, 40 plus 25 pages. Okay, so that is equals to 65 pages. Or the another possible combination can be, that is I give these 3 books to my these 3 books to my first student, that is it has to reach 60 pages, then fourth book to my second student, and last single book to my third student. So these are the possible combination, or there can be many possible combination, but I am taking these 3 just in concern for now, just to explain you the concept of like what this question is asking me to do. Okay, so what we have to do, we are just like we are distributing this book among this m student. So what we have to do here, there will be at least one student that has to read the maximum number of pages, right? So here, that is my third student, here is reading the maximum number of pages, that is equals to 95, right? In this combination, in this permutation, or in this distribution, my maximum number of pages that my student has to read is 65. In this combination, in this distribution, the maximum number of pages that my student has to read is 60. right? So I have to return this 60. That is the maximum number of pages that one student has to read in all the distribution should be minimum. Like it is the maximum in between all these three students, but it is the like minimum in this distribution, right? So we have to just minimize the load on a student, load on the student that has to reach the maximum page, maximum number of pages of book, right? So we have to return the 60. Let's say, and my major constraint is that I have to allocate memory in contiguous manner. That is, if I allocate this 20, 10 and 30 to my first student, right, I can allocate in this manner. I cannot allocate, that is, if I allocate this 20 to my first student and then I allocate 40 to my first student, it is not allowed. If I allocate him, I'm going to allocate this first book, then the second book to my second student, right? That is the third book to my second student. In this way I cannot allocate in like discrete manner, right? I have to allocate in contiguous manner. Okay. And another concept was that if I have 3 students, then I have to allocate at least one book to all of my students, right? Okay. So what I was telling about this max here is written here in this question, in this line, that is, there can be many ways or permutation to do so, that it says that there are that, let's see here that there are many distribution we can perform, but in each permutation, one of the m student will be allocated the maximum number of pages that you can see here in each distribution, that is in this distribution and in this distribution and in this distribution. At least one student have to read the maximum number of pages. All right. And after that, what it is saying, the task is to find that particular permutation in which the maximum number of pages allocated to a student is minimum in those of minimum of those in all other permutation, and print them in this minimum value. So what it's saying, the maximum number of pages in that particular permutation should be minimum, right? So in this permutation, the maximum of number of pages that a student has to reach is less than the maximum number of pages in this distribution and this distribution, right? So we are going to consider this, and our answer will be 60. Okay, my answer will be 60. All right. So I hope I was able to make it clear to you. So let's again discuss the approach. Sorry. Okay. So what if I am given an invalid argument? Let's say what my invalid argument is going to be. Let's say if my m is greater than my n. If my m become greater than my n, it means, let's say I have 5 students and I have only 3 books. So is it a possible combination? Are these a is it a like a valid argument? No, it's not, because 5 students are there and I have to allocate 3 books. So I cannot break the book, right? I cannot just torn the pages of my book and allocate some pages to a student, some pages to a student, some pages to a student. We are not allowed to do that, because we have unbreakable items, right? So my first constraint was that allocate at least one book to my student, at least one book to every student, to each student. Okay. Second was contiguous allocation. Contiguous, that is, we have to allocate like in this manner, like contiguous, that is the first and the second, or the first, second, third, right? In this manner, not in this way, that is the first and the fourth. This is not allowed. Contiguous allocation should be there. And the third one is what was my third constraint? My third constraint was we have unbreakable items, right? We cannot break our books, we cannot torn the pages, or we cannot just like break it, right? So we have unbreakable item. Okay, so let's discuss the approach. And even if I again say, if if my number of pages, that is my number of students, is equal to the number of books, so what will be my answer? My answer will be what? The maximum of my array, right? Why maximum of my array? Because when this is the when my number of books is equal to my number of students, then my allocation should be equal to what? My allocation is going to be like this. Wait, let me just erase all this. Let's say my m here is equals to 5, right? if my m is here equals to 5, so I allocate first book to my first student, second book to my second student. That is, I allocate each single book to my every students, right? My student 5/5 is allocated with 20 book with 25 pages, right? So the maximum load on a student is going to be what? Is going to be the max of the array, right? Because uh, at least one student has to read this book now with the maximum pages, right? So my answer is going to be the max of my array max. Like my answer is going to be the max of my array when my m is equals to n. Okay. Now let's discuss when my m is less than n. So let's say I have two students and I have this much possible combination. Okay. So for my m is equals to 2. Wait. M is equal to 2. What my answer is going to be? Let's see. My answer are going to be like this. To my first student, I allocate this book, first book, and then all these books are read by my second student. So the maximum load on the second student is going to be 10 plus 30, that is 40 plus 40, 80 plus 25, 105. Okay. Another allocation can be my first, like my first student is reading this book, first and second book. So my load will be here 30 and 95. Okay. Another possible combination, my first student is reading all these three books. That is, my load is 60. And second student is reading these two books. My load is 75. Another possible combination can be here. What it can be? It can be, let's say, my first student is reading all these four books. That is, the load here become equal to 100. And the last one is reading the last book. Alright. These are my possible distribution. So what will be my answer here? So the maximum load on a student here is 75. So my answer is going to be 75 because it is the minimum of all this distribution, right? Okay. So let's see how we are going to apply binary search here. Now let me tell you one thing now. Now I'm going to tell you something. Let's make another page. Let's make an array again. Okay, this is my array, and what was my element? 20, 10, 30, 40, 25. 20, 10, 30, 40, and 25. Okay. Now, if I say what can be the lowest maximum load that my student can handle, so my lowest maximum load that goes to my that my student can handle will be equal to what? The max of my array, right? Because the lowest maximum load any of my student can have is going to be equal to the max of my array, because this book is read by at least some boy, right? Some student, because any student is going to read this book. So the lowest possible maximum load on a student can be 40, right? Because this book is read by someone, right? This book is definitely going to be read by someone. Now the highest maximum possible load, that is now the highest maximum number of pages that my student can read can be equal to what? It can be equal to the sum of all the pages of the sum of the pages of all the books, right? That is, here it is equal to 60 plus, it is equal to 125. Why am I saying this 125? I know this cannot be equal to, like, my maximum load cannot reach 125, because if I say my maximum load reach 125, I'm giving a student a load of 125. It means that I'm allocating all the books to my single student, which is not possible. But I'm just setting a range here that any student should handle at least should have the capacity of reading at least the book with the maximum pages, that is 40, right? Okay. They should have the capacity of reading at least this book. Their lowest maximum capacity should be of this reading this book with the maximum pages, because any student has to read this book, right? So every student should be capable of reading this book. Okay. Now, and the maximum possible load my student should handle, can have can have to handle my, like my the maximum highest maximum load my I can give to my like I can load on my student can be equal to, can reach to 125, right? I can allocate like all the books to my single student if possible. If I have student is equals to one, if I have only one student, then I have to assign all the book to my student, right? My that single student. So okay. So see, it should have the capability of reading at least the book with the maximum pages, and I can I can increase the load also, right? So my highest to maximum load can is going to range between this 40 to 125. Okay, I am just setting a range here. So let's see how am I going to apply binary search here. Okay, now let's just erase this. My lowest low is equal to 40. My high is equal to 125 here. Okay, and let's say my m is equal to 3 here. Okay, all right. Now I'm going to calculate my mid. 40 plus 125 is equals to 165 by 2. 165 by 2 is equals to 82. Okay, now my load is, let's say I set my load to 82. That is, I say each of my students that you should have the capability of reading at least 82 books, because I am going to assign the book in such a manner that you have, that any of you have to read the book, have to read the book with a load of 82. Okay, I, I am again repeating my words. That is, I am telling you that my each of my students should have the ability of reading at least 82 pages, right? Because I have only 3 students, so I am going to assign book in such a manner that any of the student has to reach the book with 82 pages. Okay, I mean, I'm just setting this combination is going to be like this, that you have to read the pages less than or equal to 82. Okay, because my combination is going to be like this. Now what I say, I check here. Now I check here. I have, let's say, 3 students. So I check here. I keep a sum here. I check here. Can my first student read the book with 20 pages? So it says yes, because I have set its capacity to 82. So it says yes, I can read this book. My capacity is 82. Now I say okay, then read the second book also. So it says okay, I can read, because you are giving me a sum of 30 pages. I can read this because my capacity is 82. Now I say read the third book also. It says okay, you are giving me 60 pages. My capacity is 82. I can read this. Now I say read the fourth book also. It says no ma'am, I cannot read this book because it's not my capacity. It is like more than my capacity. So I say okay. I ask another student. So my student 2. I reach to my student 2. I ask him to read this book with 42. It says okay, I will. Then I ask him to read this book with page 25 also. So it says okay, I can read this book, right? But I'm not going to do this because I'm going to assign this book to third students also, because it is going to sit right there. Okay, so yes, it is possible that I have a I can have give the load of 82 to my student, right? So it is possible. So now what am I going to do here? It is for, if it is possible, then I will say it means I can like, if it is possible, that is my 3 student can handle a load of 82. I say why to give them a load of 82 if it's possible to allocate the book between only 2 students by keeping a load of 82, just reduce the load. So what do? I reduce this highest load. I reduce this load to mid minus 1. So my low is now 40, my high is now 81. Okay, now I again calculate my mid. I again calculate the load that I should give to my student. Like the I again set a range. Like again I again set a target that my student should be able to read this much pages of book. So my 80 plus 80 plus 40 here is equals to 81 plus 40 is equal to 121 by 2, which is equals to 60. All right. So my load here now is 60. Okay. So I again ask my first student, can you read this book with 20 pages? It says yes, my capacity is 60. I can read this book. I can read the second book also. I can read the third book also. Now I ask second student, I ask him to read the 40 book with 40 pages. It says no, my capacity is 60. I cannot read. I ask second student, can you read this book? It says yes. Then I say read the book with 25 pages also. It says no, ma'am, I cannot because my capacity is of 60. You are assigning me 75 page, 65 pages, which is not uh, possible. So I say okay, I assign this book to student 30. So it is possible that by keeping a load of 60 pages, I can distribute this book in between among these three students, right? Now say okay, if it is possible that my students are able to bear this much load, I say okay, let's just again reduce the load. If it's possible to reduce this much, like if it's possible to distribute book by keeping this much load in among the three, so let's just reduce the load. Okay, why to keep this much load on student? So I just reduce the load. I reduce my load to mid minus 1, that is now it become equal to 59. 60 minus 1, which is equal to 59. So my high now become equal to 59. Okay, now I again calculate my mid. Again calculate my mid. So my mid is going to be 40 plus 59 by 2. Okay, which is equals to 109 by 2, which is equal to 54. Okay, now again check. I ask student 1, can you read the first book? It says yes. Can you read the second book? It says yes. Can you read the third book? It says no, ma'am, my capacity is of only of 54 pages. I cannot read this book. Ask another student. It says, can you read the book with 30 pages? It says yes, I can read the book with 30 pages. I ask, can you read the book with 40 pages also? It says no, ma'am, I cannot. So I ask third student, can you read this book with 40 pages? It says yes, ma'am, I can read this book with 40 pages because my capacity is of 54 pages, so I can read this book with 40 pages. So now I ask him to read the third book also. It last book also. It says no, ma'am, my capacity is of just 54. How can you assign me this book of 65 pages? It says so. I say no, it's not possible that by keeping a load of 54 pages, I cannot assign this book among the three students, right? Because they are not capable of reading this like book with like the pages more than 54. So what I say just increase their capability to mid plus 1. Okay, so I am going to increase this their capability by mid plus 1. So I ask them to increase their capability to 51, like mid plus 1. So now low become equal to 55. Now my high is equal to 59. I again calculate my mid. I again calculate my mid. So now my mid here is 55 plus 59. Okay, 55 plus 59 is equal to what? 114 by 2, which is equal to 57. Okay, now I again ask my student, can you read this book? It says yes. With 20 pages I can read 10 pages. I cannot read but 60 pages. Okay, so I assign him 20 pages. Now I assign my second student the 30 pages only because I cannot assign the book with 40 pages because its capacity is of 57 only. Now student third, I assign him the book with 40 pages. Now this book is remained, right? So what do I have to do? It's not possible to divide. I again have to increase their load. If I again increase their load to mid plus 1, my low become 57, 57 plus 1, which is equal to 58. Okay, now 58 plus 59, which is equals to 117. Now 117 by 2, which is equal to 58, right? Is it possible to divide them with 58? No, it's not possible. Let's see how. My low was 58 and my low was 58, my high was 59. Okay. High was 59. Okay. Now if I do this, it was 57 initially. Now if I do this, 58. Okay. I again check. It's not possible because my first student can read these two books. My second can read this book. My third can read this book only. Okay. One book will be remained, right? So what I do here, now I again increase my capacity to mid plus 1. My low become equal to 59. Now 59 plus 59. by 2, which is equal to 59 itself. Now again check with 59. Is it possible? It's not possible, right? So now what do? I again increase my load to 60. When I increase my load to 60, my iteration stop. Why? Because here my is increased to, my low is greater than high, right? Right? Because I can only give this much pressure and I'm increasing the pressure on my student, right? By 60. It is not possible. So highest pressure can be equal to what? Now my highest pressure here can be equal to what? 60. When my low is greater than high, so my pressure is going to be only 60. 60 here, okay? 60 here or 59. Let's just see here what it's going to be. Okay, so now when we calculate now our mid, so it become equal to what? 60 plus 59 by 2, which is equals to 59. Okay, so this is going to be my answer. Now let's try to calculate this. How? Let's erase this. My mid is now 59. Mid is 59. So this is going to be my answer. Now let's check. Okay, 59, or it is going to be 60. Now let's check here. Okay. So first I say allocate this book to my first student. Okay. These two books to my second book to my second student, and these three books to my third student. That is going to be 30, 40 plus 70, 25, which is equal to 95. Okay. Another distribution. My first student read this two book. It has a load of 30. My second student read this book 30. My third student read this two book. So it is again equal to, it's equal to 75. Now my first student read these three book. Its load is 60. My second student read this book only, so load is 40. My third person read only 25 book. Okay. Alright, this was my possible combination. Or it can be my first student read this two book. It is equal to 30. My second student read these two book is equal to 70 here. My third student read only the third book. Alright. So here the maximum here is 70, the maximum here is 60, the maximum here is 95, the maximum here is 75. So my answer is going to be what? 60 is the minimum, all the 60 is the minimum of all these answers, right? Even if it's the maximum number of pages for this combination, but it is the minimum of all the combination, right? Right? So my 60 is going to be answer here. Okay. So I hope I was able to make it clear to you. Now let's try to code this. Now the main thing that you have to understand here is that what we have to do, we just have to set a range. Okay, wait, we just have to, let me just erase all this. We just have to set a range between the low and the high, and my low is going to be what? The initially my low will be equal to the max of my array, maximum of my array, and my high is going to be the my high can be equal to what? All the number of pages that my student have to read. So all the number of pages, right? That is the sum of this array. Okay, sum of array, sum of all the number of pages, right? Because it cannot go higher than this. Okay, because our student cannot have to read the number of pages greater than this, right? Sum of all the number of pages, right? Then what we have to do? Calculate mid, and if it's possible to divide this book by keeping a load of mid, then what we do? We decrease our highest load, right? So if possible that we can allocate mid by keeping a load of mid, we can allocate book between m students. So what are we going to do? We just decrease our load, right? So my high will become equal to mid minus 1, right? And if it's not possible, then what else? My low become, then do what? Then just increase the load on the student, right? This is the maximum possible load that my student can handle. All right. and this is the load that my student is bearing now, right? Is bearing. So what am I going to do? I am going to increase my load on my student, so it become equal to mid plus 1. All right, that is, you have, my highest load is this much, and you have to read the, you have to increase the load. Okay, so we are increasing our load here. All right, so what are we going to do? We will be preparing a possible array, like if possible method, which is whenever we'll keep a sum here. All right, we'll keep a sum, and whenever my sum becomes greater than my mid, then what do? I increase my student's value. I increase my student, right? Whenever sum becomes greater than mid, I increase my student value, that is, I need more student, and I return what? If my student is less than or equal to m, right? I see if my students, if the students I require is less than the number of students that I have, then it is possible to distribute this book among m student by keeping a load of mid, right? And if it's not possible, and if my number of student become greater than the number of student I have, then it is not possible, right? It is not possible by keeping a load of mid to allocate the book between m student, right? Okay, so this was the whole main concept of my applying how in, like this was the main concept, how am I going to apply binary search in this like in this method, right? Like in this problem, how can I solve this problem using binary search? Okay, so I hope I was able to make it clear to you guys. All right, sorry. Now let's code for this. Okay. Okay, so let's write some code. First of all, what am I going to have here is my sum, that is going to be my high, and my max, that is going to be my low, and my answer. All right. First of all, I will iterate over each of my element, wait, array elements, and then I'm going to calculate my max and my sum, right? And my max, if value is greater than max, then update my max to val. Okay, now what am I going to do here is, I have my low, which is equal to my max of my array, right? And then I have my high, which is equal to the sum of my array. All right, now I will run a loop while my low is greater than my high, right? Now what am I going to do here is, I will first of all calculate my mid, and mid is equals to low plus high, divide by 2. All right, now I'm going to check, because this mid of mine is going to be my load, so I'm going to check if is possible to distribute this n books among m student by keeping a load of mid. If it's possible, then my mid is my, then update my answer to my mid and reduce my load, right? So high is equals to going to be equal to my mid minus 1, right? And if it's not possible, then increase the load on individual students, so load is going to be increased to mid plus 1. Okay, all right, and return what? Return answer. Now we have to write the is possible method. Now public static boolean is possible int arr okay. All right, now first of all I will have student of number of student, that is equal to, that is initially equal to 1, and what I will be having number of student and my sum, which is initially equal to 0. Now what I'm going to do, I will look for all the pages of book with an arr dot length I plus 1. All right, now I will check if my sum is greater than mid. If my sum is greater than mid, then what? here my sum plus equal to ARR of I will continue to include my like my books till my sum become greater than my mid, right? Till becoming till the number of pages become greater than my capacity. If my number of pages become greater than my capacity, then what am I going to do? I will increase number of students, right? And my sum become, that is my number of pages allocated to my second student. My new student is going to be equal to the number of pages in the index I, right? And what am I going to return? Return st less than equals to m. It means it is going to check if my student is less than or equal to m, it is going to return true. And now let's try to run this once. Okay, there is some error. 36 and 23. 36. Okay, and 23. If it's possible. Okay. Now let's try to run this code. There's some plus equals to ARR of it. Cannot find symbol sum. Okay. For int I is equals to 0. Wait, there is some variable I. What's wrong with this? Okay, it's going to be val here, because I'm not accessing through index, I'm accessing each element with. Okay, accepted, and now submitted. Let's try to submit. Okay, submitted, correct answer. Now we are going to dry run this over our example, over our input. So let's and now my what is my array, what is my sample input? Let's check. My sample input is 12, 30, 48 and 10. It means we have 4 books, and my number of student is 2. 12, 30, 48 and 10. Okay, let's make an array. Twelve, 30, 48 and 10, and m is equal to 2. Okay, so initially my sum and max is equal to 0. So I calculate my sum and max. So my sum is 40, sum is what? 12 plus 30 plus 48 plus 10, which is equals to 100. Okay, so my sum is 100 and my max is 48. Okay, so my low is 48 now and my high is 100. Okay, all right. So now first of all calculate my mid. My mid will be equal to what? Low plus high by 2, 48 plus 100 by 2, which is equals to 148 by 2, which is equal to 74. All right, my mid is 74. Now I'm going to call is possible method. So my is possible will return what? It will return, let's see, it will return true, right? Because it's possible by keeping a load of 74 to allocate my books between 2 students, right? I assign first this 2 book to my first student and this first book to my first student, let's say. It returns true. So what am I going to do? My answer now become equal to 74. Okay. So what do I do? If it's possible, then my high, I say just decrease the load. Now my high become equal to mid minus 1. So my high is now 72. Okay. My high is now 72. Sorry, 73. Let's just undo it. Okay. My high is now 73, which is equal to mid minus 1. 73. I again calculate my mid. So my mid is equal to 48 plus 73, which is equal to 121. Okay, 121. Right. 121 by 2, which is equal to 60. Right. So my mid is 60 now. If my mid is 60 now, I again check, is it possible? So it says yes, it is possible. So now my mid is uh, updated to 60, and my high is now updated to mid minus 1, which is equal to 59. So my high become equal to 59 now, right? Now I again check, I again calculate my mid. So 48 plus 59 become equal to what? By 2 become equal to what? 99 plus 1107. Okay. 107 by 2 is equal to 53. Okay, my mid is 53 now. Mid is equal to 53 now. All right. I again check by keeping a load of 53. So it says no, it's not possible. Okay, because see here, I cannot allocate more than these 2 books to my first student and more than this to my, like more than 48 to my second student. So I will need third student for to read this book, right? So my it will say, it will return false. So my low become equal to mid plus 1. I increase my load, right? So if I increase my load, it says my load become equal to mid plus 1, which is it become equal to 54. My high is 59 and my low is 54. All right. I calculate my mid, which is equal to 54 plus 59 by 2. So which is equal to 113 by 2 is equal to nearly equal to 56. All right. Now my mid is equal to 56. Okay. So let's try to rub this. My mid is 56. Mid is equal to 56. It checks for 56. Is it possible? Is it possible for 56? No, it's not possible for 56. It returns false. We increase our low to mid plus 1. If we increase our low to mid plus 1, so it becomes 57. High is 59. 57 plus 59, which is equal to 116. 116 by 2, right? 116 by 2. 116 will return what? 116 by 2 is equals to 58. All right. So my mid is now equal to 58. It checks for 58. Is it possible for 58? So yes. I assign first this 2 book to my first student, this 2 second book to my second student, right? So it is possible. So now what do? My answer become equal to mid. So my answer is now 58. All right. I decrease my high to mid minus 1. My high become equal to 58. All right. Right. So I have increased my low to, okay. I decrease my high to mid minus 1. I again calculate my mid for 57 plus 58 by 2. So it becomes 115 by 2, which is equals to 57. Right. So I again calculate for my mid. It returns false, because for 57 it is not possible, right? If it returns false, I increase my low to mid plus 1. So my low become mid plus 1, which is it become equal to 58. So I again calculate 58 by 52 is equal to 58, right? 58 by 2 is equals to, it return now my mid is equal to 58. If my mid is 58, I again calculate for 58, like check is possible. Yes, for 58 it's possible. So what do? My answer is updated to 52, which was already 52, right? And my high become equal to mid minus 1. So what was my mid? My mid was 58. So my high is mid minus 1, which become equal to 57, right? So my loop terminates because my low is 58. My high is lesser than mid minus 1, right? My high is lesser than 58. So my high is less than my low. So the loop terminates. So let's see if the answer is 58 or not. So yeah, my answer is 58, right? So I hope I was able to make it clear to you guys. And if you like this video, please like, share and comment. And thanks for watching.